Okay, so module 15, and as I said, Friday we're doing 16 and 17, and that'll actually be the last chapter for the last bit of the introduction to networks. And then we're actually going to move on to switching, routing, and wireless essentials. Little bits of it. So of course, this is about the application layer. So we're going to talk about, as far as the OSI model is concerned, the application, presentation, and session layers, which of course are all blended together in the TCP/IP application layer. We'll talk about how end-user applications operate in a peer-to-peer network. We'll look at the web and email protocols. We'll look at DNS and DHCP, and we'll look at how file transfer protocols operate. Okay, so as I said, the top three layers of the OSI model are equivalent to the application layer of the TCP/IP model. And so, of course, the application layer provides the interface between the applications used to communicate and the underlying network which messages are transmitted through. Some of the most widely known application layer protocols include HTTP, FTP, TFTP, IMAP, and DNS. And so they do web, file transfer, email, and of course, name resolution. So the presentation and session layers are, of course, part of the OSI model, but of course, blended into one in TCP/IP. And so, of course, the presentation layer is all about formatting or presenting data at the source device into a compatible format for receipt by the destination device. Compression can happen also on this layer, and encryption can happen on this layer as well. When it comes to the session layer, it creates and maintains dialogues between source and destination applications. It handles the exchange of information to initiate dialogues, keep them active, and to restart sessions that are disrupted or idle for a long period of time. Now, when it comes to TCP/IP, of course, application protocols specify the format and control information necessary for many internet communication functions. Application layer protocols are used by both the source and destination devices during a communication session. The communications to be successful, the application layer protocols that are implemented on the source and destination host must be compatible. And so, of course, when it comes to DNS, it uses both TCP and UDP, and it uses port 53. Now, of course, TCP is only used for zone transfers between servers that share the DNS duties, while UDP is used by client request and response messages. And so, of course, the point of it is to translate domain names such as Cisco.com into IP addresses, which, of course, the computer can use. Now, DHCP, the server listens on port 67. The client actually listens on port 68 for the response. And so, of course, as the name suggests, it dynamically assigns IP addresses to clients, and of course, these are available to be reused when they're no longer being needed by some other client. So when it comes to the web or HTTP, or hypertext transfer protocol, ports 80 and 8080 are typically used. 80 is the more common one, of course. A set of rules for exchanging text, graphical images, sound, video, and other multimedia files on the World Wide Web. So, of course, you download a HTML, and of course that will often have links to pictures and maybe databases and movies and sound and whatever else it might be. All right, so peer-to-peer networks. So client-server processes are considered to be in the application layer. In the client-server model, the device requesting the information is called a client, and the device responding to the request is called a server. Application layer protocols describe the format of the requests and responses between clients and servers. In peer-to-peer networks, two or more computers are connected via a network and can share resources, such as printers and files, without having a dedicated server. Every connected end device, known as a peer, can function as both a server and a client. One computer might assume the role of server for one transaction while simultaneously serving as a client for another. The roles of client and server are set on a per request basis. And so here they're saying that there's two hosts connected to one another. One is sort of sharing files on the network and the other one is sharing a printer on the network. And so they're both being a server in that case, but of course when it comes to the files, it is a client for the file server, but of course it's also being a server for the printer. And so it's doing both at the same time. Now there are peer-to-peer applications as well, and so they allow a device to act as both a client and a server in the same communication. Some peer-to-peer applications use a hybrid system where each peer accesses an index server to get the location of a resource stored on another peer. And so common peer-to-peer applications, each computer in the network that is running the application can act as a client or a server for the other computers in the network that are also running the application. So of course, some examples of peer-to-peer applications, of course, BitTorrent, Direct Connect, eDonkey, and Freenet. Now, BitTorrent is often thought of as to be a bit on the shady side, and yes, a lot of the traffic that does move via it can be shady, but if you've ever downloaded an ISO for Linux, you can often download that from BitTorrent as well, and it's normally a lot quicker. So it doesn't have to be illegal, it's actually just whatever content you might be downloading may well be infringing someone's copyright. Alright, so web and email protocols. Alright, so Hypertext Transfer Protocol and Hypertext Markup Language, or HTML. So when a web address or URL, which is a uniform resource locator, is typed into a web browser, the web browser establishes a connection to the web server. The web service is running on the server that is using the HTTP protocol. To better understand how the web browser and server interact, examine how a web page is open in a browser. So the browser interprets the three parts of the URL. So the first part here, HTTP, well, that's actually just specifying what protocol we're going to use. And so it's HTTP, so it's unencrypted web page. And of course we use a colon and two slashes to separate that from the rest of the URL. And so of course the next part is the name of the server we wish to connect to. And so of course it's actually the machine's name is www that belongs to the network, cisco.com in this case. So that's just a host name and that's the rest of its domain name. So that plus that makes it a fully qualified domain name. So it's a computer name in its network, and so that's an FQDN. And then index.html is actually specifying which page on that web server we wish to use. Or file, I suppose, really. Now, the browser then checks with a server to convert www.cisco.com into a numeric IP address, which it uses to connect to the server. So, you know, cisco.com is good for us, not good for a computer. And so the client initiates a HTTP request to a server by sending a GET request to the server and asks for the file index.html. And so, of course, the server will respond to that request and the server sends the HTML code for this web page to the browser. And so then the browser deciphers the HTML code and formats the page for the browser window. Now, of course, rarely is a page going to be just HTML. How many sites don't have images on them at the very minimum? And so once it's interpreted the HTML code, it's probably going to have a link to a picture that you need to download and a whole pile of other things as well. And so there's going to be some extra downloads that are going to have to happen for other files. Again, that will all be on a GET response basis. All right, so HTTP is a request response protocol that specifies the message types used for that communication. The three common message types are GET, POST, and PUT. GET, this is a client request for data. A client web browser sends a GET message to the web server to request HTML pages. Post will upload data files to the web server, such as form data, and put this uploads resources or content to the web server, such as an image. Note, HTTP is not a secure protocol, it's clear text. For secure communications sent across the internet, HTTPS should be used, and pretty much the web browsers these days often will try to use HTTPS on the server, and only if the server doesn't support it will it then go back to HTTP. Okay, so that's web pages. Email protocols. Now there's a few protocols included in that. And so email is a store and forward method of sending, storing and retrieving electronic messages across a network. Email messages are stored in databases on mail servers. Email clients communicate with mail servers to send and receive emails. And so the email protocols used for operation are SMTP, used to send mail, and then there's a choice of either Post Office Protocol or IMAP, used for clients to receive emails. So basically, in this diagram here, we've got a user with an email client, I'm assuming, and so he's sending an email to recipient@cisco.com, and so his email client is going to talk to his own mail server, and it's going to send that message using SMTP, which is simple mail transfer protocol. And so that person's mail server will receive the email, and then it will actually look up the destination address. And so in this case, we're looking for the mail server for Cisco.com. So it's not a plain old DNS request. It's actually looking for a special record, so it can actually figure out who the mail server is for Cisco.com. And so that would be a DNS request. And once it knows who it is, of course, it will have its IP address. And again, we'll use SMTP to send that email from the source user's mail server to the destination user's mail server. And so once it arrives on that server, it will then be stored in the user's mailbox, basically. And then the user needs to use either IMAP or POP3 to connect to his mail server and download his messages. Now, POP, I haven't seen that used a lot recently, I've got to admit. So Post Office Protocol version 3. 15, 20 years ago, you used to have to use it. I remember back in those days, you know, you'd get 2 or maybe 10 megabytes of storage for email on your ISP server. And so you actually needed to download with POP, which would download your email and then delete it off the server by default. And so then it's your responsibility to store any of your old emails. IMAP is more commonly used these days because email services are a lot more generous in how much space they give you. And so basically it does download your emails to your local copy, but it also leaves it on the server because, you know, you've got the Gmails and the Outlooks and all of those kinds of things that actually give you multiple gigabytes or even maybe even terabytes of storage space. And so you don't need to delete your email instantly, because back in the old days, if your email box was full, all your emails would bounce back to the sender. And so not very good. That was why POP had to delete them. But these days, there's a lot more storage available to all of us, so I don't need to use POP. Okay, so when a client sends email, the client SMTP process connects with the server SMTP process on the well-known port of 25. After the connection is made, the client attempts to send the email to the server across that connection. When the server receives the message, it either places the message in a local account if the recipient is on the same server as the sender, or it forwards the message to another mail server for delivery. So, of course, I was talking about a different one when I was talking to the previous slide. The destination email server may not be online or may be busy. If so, SMTP spools messages to be sent at a later time, so it will keep trying. SMTP message formats require a message header, so a recipient email address, a sender email address, and a message body. Okay, POP is used by an application to retrieve mail from a mail server. When mail is downloaded from the server to the client using POP, the messages are then deleted on the server. So the server starts the POP service by passively listening on port 110. When a client wants to make use of the service, it sends a request to the established TCP connection with the server. The connection is established, the POP server sends a greeting. The client and POP server then exchange commands and responses until the connection is closed or aborted. Since POP does not store messages, it is not recommended for small businesses that need a centralized backup solution. IMAP is another protocol that describes a method to receive email messages. Unlike POP, when a mail user connects to an IMAP server, copies of the message are downloaded to the client application, but the original messages are kept on the server until you delete them. When a user decides to delete a message, the server synchronizes that action and deletes the message from the server. Okay, so IP addressing services. So the first one we're going to talk about is DNS. And so domain names were created to convert numeric IP addresses into simple, recognizable names. So a fully qualified domain name, such as http www.cisco.com, are much easier for people to remember than an IP address. The DNS protocol defines an automated service that matches resource names with required numeric and network addresses. It includes the format for queries, responses, and data. Now, of course, when it comes to DNS name resolution, basically you start from the right and keep moving left. So as I said before, www is actually a computer name. Yes, normally it will be a web server, but in the end result, you could actually call your web server anything. You could call it Fred, Mary, whatever it might be. It's just that it's common practice to type in www, but you actually don't need, depends on the setup, but anyway. So what we're doing is we're querying www.cisco.com. The client asks the DNS server. Now, if the DNS server knows that name, great, it will respond back, and then you can actually connect to the ciscoserver.com address. If you don't know it, that's when you have to start searching around. Well, the server does, you don't. And so there's always an implied dot at the end of a FQDN, and that is basically talks about the root servers. So if you've heard about the root DNS servers, they know the addresses of all the top level servers. And so the .coms, the .edus, the .aus, the .nzs, and so on. And so that's the first part. So of course here, the DNS server, if it doesn't know that address, would actually go to the root servers and say, all right, what's the address of the .com server? And so a root server will reply back saying, hey, this is an address to a .com server. And then the DNS server will ask the .com server, what is the address of the Cisco.com server? And so then the top level will respond back with that address. And then from there, the DNS server will actually ask Cisco, hey, what is the IP address of your host called www? Because it's the leftmost, that is the computer name, basically. And so, yeah, so basically it's computer www on the cisco.com domain is what we're looking for. And so, of course, once the DNS server has learned all that information, then it will, of course, reply to the client. And often they will actually cache an entry. So if someone else requests that same URL, it can go straight from the cache and say, I know that address, it's that. And so it doesn't have to go through that lengthy process every time. So from there, of course, you can connect to the host. Now, when it comes to DNS entries, the DNS server stores different types of resource records that are used to resolve names. These records contain the name, address, and type of record. And so some of the record types are A, which is a standard host entry. And so that's an IPv4 entry. There's an NS entry, so that's the authoritative name server for that particular domain. There's a quadruple A or quad A entry, and basically because they do that because an IPv6 address is 4 times longer than an IPv4, and so it's got 4 A's. And then the last one is an MX type of record, which is mail exchanger. And so that's the type of record that is used for those SMTP requests, is the MX record. When a client makes a query, the server DNS process first looks at its own records to resolve the name. If it is unable to resolve the name by using its stored records, it contacts other servers to resolve the name. And so that's the processes I was talking about. After a match is found and returned to the original requesting server, the server temporarily stores the numbered address in the event that the same name is requested again. So that caches the entry, basically. So DNS uses the same message format between servers, consisting of a question, answer, authority, and additional information for all types of client queries and server responses, error messages, and transfer of record information, resource of record information. And so, yeah, as I said, we've got the DNS hierarchy, which I've pretty much already covered. And so you've got your root level servers, then you've got your top level servers, and so .com.au. So basically the last part of the URL or fully qualified domain name. And of course the second level domain ones, of course, Cisco.com is off of .com. And so of course if you were resolving tafsa.edu.au, of course you'd go to the root server, it'd tell you about AU, then you'd have to ask AU about .edu AU, and then at .edu.au you'd then have to ask for tafsa. And so just an extra step in the process. So each DNS server maintains a specific database file and is only responsible for managing name to IP mappings for that small portion of the entire DNS structure. When DNS server receives a request for a name translation that is not within its DNS zone, the DNS server forwards the request to another DNS server with the proper zone for translation. And so, yeah, as I said, starts from the top, works down. Starts from the right and works left. Okay, now you can test DNS with the NSLOOKUP command. So NSLOOKUP is a computer operating system utility that allows a user to manually query a DNS server configured on the device to resolve a given host name. This utility can be used to troubleshoot name resolution issues and verify the current status of the name servers. When NSLOOKUP command is issued, the default DNS server configured for your host is displayed. The name of a host or domain can be entered at the NSLOOKUP prompt. So if you just type in NSLOOKUP, you'll actually go into an NSLOOKUP sort of interactive mode. And you can then make a whole series of requests. You could just do NSLOOKUP space www.cisco.com. It will just look up Cisco and then return you back to your normal prompt. All right, DHCP. So of course that's Dynamic Host Configuration Protocol. For IPv4 service, service automates the assignment of IPv4 addresses, subnet masks, gateways, and other IPv4 networking parameters. DHCP is considered dynamic addressing compared to static addressing. Of course, static addressing is when you type it in manually into each computer. When a host connects to the network, the DHCP server is contacted and an address is requested. The DHCP server chooses an address from a configured range of addresses called a pool and assigns or leases it to the host. Many networks use both DHCP and static addressing. DHCP is used for general purpose hosts such as end user devices. Static addressing is used for network devices such as gateways, switches, servers and printers. Now DHCP for IPv6 provides similar services for IPv6 clients. However, DHCP version 6 does not provide a default gateway address. This is only obtained dynamically from the router advertisement message from the router. So how does DHCP operate? So when the client boots, it actually sends a DHCP discover message, which says, hey, big world out there, is there a DHCP server? Big world, I mean the local subnet. And so, of course, the destination is actually a broadcast. The source address is actually all zeros because the host hasn't got an IP address yet, so it doesn't know what to fill in as the source address. But, of course, it does know its own MAC address, and that's actually how it can be configured, addressed, and also how it can be sort of kept track of. So with that DHCP discover message, if a server does see that discover, it will actually send what's called an offer. And so it actually says, hey, I've got an address for you, which offers a lease to the client. If a client receives more than one offer due to multiple DHCP servers on the network, it must choose one, normally the first one it gets. So if it gets an offer, it will accept one and send a DHCP request to that server. And so, of course, because this would have had a source address, it will know who the destination to put it on. And so that's the DHCP request, and identifies the explicit server and lease offer that the client is accepting. The server then returns an acknowledgement message that acknowledges to the client that the lease has been finalised. If the offer is no longer valid, then the selected server responds with a DHCP negative acknowledgement message, and the process must begin again with a new DHCP discover message. I don't think that happens particularly often. Now, DHCP has a set of messages that is very similar to those, but we don't use that. We use solicit and advertise, information request and reply. So basically the same process. So it's DHCP solicit, DHCP advertise, and then information request, and then a reply. All right, file sharing services. So FTP, File Transfer Protocol, was developed to allow for data transfers between a client and a server. An FTP client is an application which runs on a computer that is being used to push and pull data from an FTP server. So you can download it, and sometimes you can upload depending on the permissions on the server. So step one, the client establishes the first connection to the server for controlled traffic using TCP port 21. The traffic consists of client commands and server replies. So step two, the client establishes a second connection to the server for the actual data transfer using TCP port 20. This connection is created every time. I can't move that off the screen. Bloody. The client establishes a second connection for the actual data transfer, and that's port 20. The connection is created every time there is a data to be transferred. The data transfer can happen in either direction. The client can download or pull data, or the client can upload or push data to the server. Okay, server message blocks is another protocol. And so that's actually a Microsoft protocol. And that's actually how you talk to Mac Drive. And so we've all probably got an L drive here. That's actually using Samba, or SMB, sorry. It's called Samba when it's used on Linux boxes. So server message blocks is a client-server request-response file sharing protocol. Servers can make their own resources available to clients on the network. So the three functions of SMB messages are to start, authenticate, and terminate sessions. You can control file and printer access. You can allow an application to send or receive messages to or from another device. Unlike the file sharing supported by FTP, clients establish a long-term connection to servers. After the connection is established, the user of the client can access the resources on the server as though the resources are local to the client host. So that's why we get that, when you log in, you should be getting an L drive. It looks a bit like it's a local drive. We all know it's actually on the server, but it looks like it though, doesn't it? And as far as the application's concerned, it's actually the same thing. So if you're using Word and you save it to C drive, or if you're using Word and you save it to L drive, it actually doesn't feel any different to us, and also the application actually doesn't know that it's any different. It's actually that's a specific application layer protocol that basically emulates a local drive when it's actually a remote drive, and so works very nicely, very seamless solution. Okay, that's it for the chapter. Bit of a recap. And so the application layer protocols are used to exchange data between programs running the source and destination hosts. The presentation layer has three primary functions: formatting or presenting data, compressing data, and encrypting data for transmission, and decrypting data on receipt. The session layer creates and maintains dialogues between source and destination applications. In the client-server model, the device requesting the information is called a client, and the device responding to the request is called a server. In a peer-to-peer network, two or more computers are connected via a network and can share resources without having a dedicated server. They'll each sort of take on the job as server and client. The three common HTTP message types are GET, POST, and PUT. Email supports three separate protocols for operation: SMTP, POP, and IMAP. Not that you'll use POP much these days. DNS protocol matches resource names with the required numeric network address. DHCP for IPv4 automates the assignment of IPv4 addresses, masks, gateways, and other IPv4 parameters. DHCP version 6 works much the same way. They've just called the messages different names. An FTP client is an application which runs on a computer that is being used to push and pull data from an FTP server. Three functions of SMD messages are start, authenticate, and terminate sessions, control, file, and printer access, and allow an application to send or receive messages to or from another device. That is the logo. So there's 2 more chapters to go for Introduction to Networks, and we start on routing, switching, and wireless essentials. All right, see you then.